Welcome back to 12.9, Solving Rational Expressions. So again, we've been working with rational expressions the whole time, but we've just been simplifying them. Now we're talking about how do you actually solve for the x or the n or the a value as you work through these problems. So solving rational expressions. Rational expressions are expressions that contain a rational expression, obvious. You can use cross products to solve rational expressions, but only when both sides of the equation are single fractions. So what we're going to be doing in the first set is using our equal sign to our advantage. We can use cross products if two equations are said to be equal. We know that about ratios. And then as we move forward, we're going to be talking about how do we use our least common denominator to our advantage to no longer be working with fractions, so that we're only working with single-lined expressions. But example number 1 gives us the expression 12 over x plus 5 is equal to 4 over x plus 2. Because they're set equal to each other, through this equal sign right here, this expression regarding whatever x is equal to whatever this expression is once you plug in x. Because of that, proportions tell us we just do cross products to solve this. We do 12 times x plus 2 is equal to 4 times x plus 5. We get 12x plus 24 is equal to 4x plus 20. Bring your variables to one side and your constants to the other. Oops, 12x minus 4x minus 4x, 8x. Now minus 24 minus 24. 8x is equal to negative 4 because 20 minus 24 is negative 4. Divide out your 8 and we get x is equal to negative 1/2. So we didn't have to get common denominators. All we did was use cross products to solve. Another method you can use to solve rational expressions is to multiply each side of the equation by the least common denominator to eliminate the fractions. So this is kind of a fun way to solve these problems. If you don't want to have to worry about getting common denominators between each of your fractions. I'm going to try to tilt you up a little further again. Whoop. There we go. All right, so example 2. Example number 2 says to solve this fraction, n minus 2 over n minus n minus 3 over n minus 6 is equal to 1 over n. Now I'm going to erase that right there. That little light spot is just going to have to be there. Oh well. All right, so typically what we would do is we would be concerned about the fact that we have an n minus 6 and just a single n again as our denominator. It would be like, oh my goodness, how do I get to a common denominator of n minus 6? Well, with this method, we're actually going to eliminate all of our denominators. Remembering that our least common denominator is a combination of all of our unique terms through multiplication. So our unique terms are n and n minus 6, which means our least common denominator has to be n times the quantity of n minus 6. That's going to end up being our least common denominator. So what we're going to do is we're going to multiply the entirety of both expressions just by our least common denominator to be able to cancel out our actual numerators. So I'm going to take my least common denominator and I'm going to multiply it by each term. I don't know if I'm going to actually be, how do I get rid of that sunspot? I don't know. Okay, we're not worrying about it. All right, so our least common denominator is n times the quantity of n minus 6. And now I'm going to multiply it by n minus 2 over n. And I'm going to multiply it again by our negative, our negative n minus 3 over n minus 6. So minus the quantity, and this is all over 1, just to be clear, of our least common denominator, n times n minus 6. I'm trying to figure out how to write this nice and small now, because it's going to continue on to the next line, which isn't ideal. All right, bear with me, guys. We're going to turn this sideways. That way we have a little bit more room. The thing that's tough with these problems is they're really long, and so trying to figure out how to do them on these little whiteboards is kind of hard. Okay, so I'm just rewriting what I just said. Our least common denominator is n times n minus 6 over 1, and we're multiplying it by each part of our original problem. So now we have that times our first term, which is n minus 2 over n, minus n times n minus 6 over 1 times our second term, which is n minus 3 over n minus 6. That's now equal to n times n minus 6 over 1 times our last term that was on the other side of the equal sign. And now we're going to go back through and we're just going to cancel out everything that overlaps. So starting over here, our n's canceled out. We don't have a denominator anymore. That's what we want. Here, n minus 6 cancels out, and we don't have a denominator anymore. So far, we only have denominators of 1. And now again, the light spot is right in the way, but our n's are going to cancel out, and now we don't have a denominator anymore. And now we're going to go back through, and we're just going to start multiplying. We have n minus 6 times n minus 2, but we're going to leave it in factored form for right this second. So n minus 6 times n minus 2, all over a denominator of 1 because our denominator canceled out, minus n times n minus 3. And again, we're not going to multiply it yet. We're just writing out our line so we can see clearly where we're at. N times n minus 3 is equal to n minus 6 times 1, so just n minus 6, because our denominator canceled out. So now it's a little more friendly of a problem to solve. After we multiply out n minus 6 times n minus 2, we're going to get n squared minus 8n plus 12 minus n squared plus 3 is equal to n minus 6. And now we can solve by adding our like terms. We have n squared minus n squared here, so wah! You almost fell. Our n's can cancel out. Now we have a negative 8n, and no other n terms that I see right away. Oh wait, this is supposed to be a 3n. There we go, now we have a negative 8n plus 3n is going to become negative 5n plus 12 is equal to n minus 6. Subtract our 12 to both sides, plus this n to the other side. We get 4n, 12 canceled out, n's canceled out, is equal to negative 18. Divide out your 4. Oh, oops. I actually had to subtract this n because it was a positive n. That changes things. Negative 5 plus negative 6. Negative 4 is negative 6. There we go. Once you get to the end and you're like, oh wait, that doesn't divide, it's always a good time to double check your work. Negative 6, divide out your negative 6, n equals positive 3. So, albeit kind of a long process, we were still able to solve for our missing variable. Let's see if that helps our light problem. Nope, turning on that light did not change the fact that there is a big sunspot right above this board. Oh well. All right, we're going to go on to example 3, multiple solutions. We're not going to do all of the examples for this one because there are 100 examples in this one. So we're just gonna kind of work around and pick the best ones. There, we'll just move the board right there. This is gonna drive me crazy the entire video, but oh well. All right, example 3, multiple solutions. Solve the following expression. So for example 3, we are told to solve -4 over a plus 1 plus 3 over a is equal to 1. So again, step 1, what is our least common denominator? Our least common denominator is the product of every unique term in our denominator, so just a plus 1 times a. That's our least common denominator. Least common denominator, a times the quantity of a plus 1. And the way we're solving the problems again today is just to multiply each term by our least common denominator to be able to cancel out any of our fractions, really. So starting here with -4 over a plus 1, I'm going to multiply it by the quantity a times a plus 1. So a times a plus 1, which is all over 1, times -4 over a plus 1, plus, now to my second term, a times a plus 1 over 1 times the term, and again, to whatever it's set equal to, a times a plus 1 over a denominator of 1 times 1 over 1. And now we're going to go through and do our canceling. A plus 1 cancels out. A and a cancels out. Here, nothing cancels out because it's just 1. Super easy. And now we're going to multiply whatever we have left. So a times -4 is going to be -4a. And now we've taken care of that whole one. We have 3 times the quantity of a plus 1. So a times 3 is going to be 3a plus 1 times 3 is 3, is now equal to 1 times a plus 1, which is going to be a times a plus 1. And that should be our line. And now we're going to go back through, add together our like terms. And just to multiply this out, a times a is a squared plus a, because a times 1 is just a. So over here we now have a squared plus a. Bringing together our like terms, -4a plus 3a is just going to be -a plus 3 is equal to a squared plus a. So I'm going to bring my like terms together, and I am going to subtract a to the other side. Or not subtract it, I'm going to add it because it's a -a. Plus a, these cancel out, and I'm going to subtract 3 to the other side. 3 cancels out, so now I have 0 is equal to a squared plus 2a minus 3. And now I have to factor this to be able to solve for a. I'm going to erase the top so that our 1, we have work space, and then 2, so that our eyes know what we're working with now. What are our factors of -3 that sum to +2? It's going to be 3 times -1. So this whole thing factors as 0 is equal to a plus 3, a minus 1. So what are our values of a now? Set each term equal to 0, and then just state your value. We have a is equal to either -3 or +1 once you add them to the other side. And so now we've solved for our 2 possible values for a. Flipping the page because we're going to skip example 4 and example 5. We're going to move on to example 6, extraneous solutions or no solutions. So reading right above example 6, multiplying each side of the equation by the least common denominator of 2 rational expressions can yield results that are not solutions to the original equation. Recall that such solutions are called extraneous. And then just, again, for y'all's sake, Remember, extraneous solutions are just the solutions that make your denominator equal to 0, which breaks down your whole problem. It just doesn't work. You can't have that. So you list your extraneous solutions by saying x can be really any value aside from anything that sets it equal to 0, such as these two numbers. So looking at number 6, example number 6, we're told to solve for 3x over x minus 1 plus 6x minus 9 over x minus 1 is all equal to the whole number 6. So step 1 is you need to figure out what your least common denominator is. And in this case, it's actually quite simple because our least common denominator is just x minus 1. But regardless, we're still going to go through the process of multiplying my entire equation by x minus 1. So if my original problem is 3x over x minus 1, I'm going to do x minus 1, again that's over 1, times 3x over x minus 1 plus my least common denominator of x minus 1 over 1 times my second term, 6x minus 9 over x minus 1 is equal to least common denominator times 6 over 1. And now I'm going to cancel out all of my denominators. Other than right here. Right here is when our problem actually has to change for the better. And so now I'm left with 3x, because all of my denominators canceled out, plus 6x minus 9 is equal to the product of x minus 1 times 6, so 6x minus 6. And now I'm going to start solving for x. I'm going to combine these, and I'm going to get 9x minus 9 is equal to 6x minus 6. Subtract 6x over. I get 3x. I'm going to add 9, and I'm going to get a positive 3. Divide 3 over, and you're going to get x equals 1. And so it'd be great to be like, awesome, I've solved my problem, I'm done. X equals 1. But you have to go back to your original problem. Your denominator is x minus 1. So in order to know what value will make x equal to 0, thus breaking our problem, we just set our denominator equal to 0, right? And we get x cannot equal 1. That's our extraneous solution. If x ever equals 1, I'm going to have a denominator of 0, and it's going to break my problem. Well, we just solved that x equals 1 if you do this problem. So this equation's answer is our extraneous solution, meaning there's no answer to this problem. This problem has no solution because since 1 is an excluded value for x, and the number 1 is our extraneous solution, we have no solution. This problem just is a broken problem, if you will. All right. We're going to stop there and leave those as our examples. You can go ahead and start your homework.